analogy between mass and heat transfer. Here, first we are considering two equations. In heat transfer, we know the heat passing through unit area per unit time is equal to k dt by dz. That is heat transfer rate per unit area. Similarly, here the mass transfer rate per unit area is equal to d dc by dz. So if we are looking at the two equations, these two equations looks like same, but they are representing different cases. In one case, there is a mass transfer, a mass is moving, and here mass does not move, but energy is moving. Even though the considerations are different, the equations look like same, so we call them as analogy. And here if you are looking, this heat transfer is because of this temperature difference, and that temperature difference is dt, that can be called as the driving force for the heat transfer. Similarly, mass transfer is because of concentration difference, that is driving force. So if in general we can say rate of transfer of heat or mass is equal to driving force by resistance. Now molecular, so this is actually not macroscopic level. If you are going to macroscopic level, what happens is this k will be substituted by alpha, and instead of t we will write rho cpt, and there are nothing other changes, no other changes, only this one is the change. There we will get q is equal to alpha. So this is for heat transfer. For mass transfer, actually the same equation, but we write dab. So the thing is, this alpha is thermal diffusivity and dab is the molecular diffusivity. So that is also again the next analogy when we are looking at the microscopic level. Now this q and j both are fluxes, that is both are considered per unit time in unit area. So both are fluxes. Now turbulent, for if we are considering turbulent flow, then with the alpha there will be a term alpha t. So that alpha t is the thermal eddy diffusivity. Similarly, here with the dab there will be a term epsilon m, that is mass eddy diffusivity. So again that is another analogy. Now if you are this analogy is called Reynolds analogy. That means if you are finding standard number, then for this one in heat transfer, that is equal to nu by repr, and in mass transfer, that is equal to sh by resc. So again both are, even though both are set for different cases, they looks like same. So these are the main analogies in heat and mass transfer. Thank you.